Hello, I'm Miss Igo. Welcome to my classroom. In this video, we're going to be talking about solving multi-step linear equations. Before we get started with our examples, let's talk about the steps for solving multi-step linear equations. The first step is to collect like terms on each side of the equation. Well, let's back up and discuss what it means to be like terms. So, like terms, examples of some like terms would be 3x and 5x. These are like terms because they have the same variable with the same exponent. There's no exponent on the x. Another example might be 3x squared and 5x squared. So the number in front of the variable does not need to be the same, but the exponent needs to be the same, and the variable needs to be the same. So again, those are like terms. Just constants. If I just had a 3 and a 5, a constant where they don't have a variable, those are also like terms. Some examples of terms that are not like terms might be 3x and 5y. These are not like terms or unlike terms because they have completely different variables. But even if they have the same variable with different exponents, those are still unlike terms. Now, in order to add or subtract terms, they have to be like terms. They don't have to be like terms if we're multiplying or dividing them, but they do have to be like terms if we're adding or subtracting them. So that's the first step. We collect like terms on the same side of the equation. The next step is to move any variable to one side of the equation by adding or subtracting. So we want the variables on one side of the equation, and then we want to move any numbers to the other side of the equation. We do this by performing the opposite operation. So if something is being added to one side of the equation, we can move it to the other side of the equation by subtracting. Addition and subtraction are opposite or inverse operations. Multiplication and division are inverse or opposite operations. We always do addition and subtraction first, and then multiplication and division. A multi-step linear equation takes more than one step to complete. Our goal, just like with a single-step linear equation, is to get the variable by itself or isolate the variable. In our first example, we have 3x plus 1 equals 13. Our goal is to get the x by itself. So the first step in solving a multi-step linear equation is to undo addition and subtraction. So if we look at where the x is, there is a 3 connected to the x. When you see a number and a variable that are touching each other, that represents multiplication. And then we have plus 1 that's also on the same side of the equation. So like I said, the first thing we want to do is undo addition and subtraction. So that's what we're going to do. We're going to undo this plus 1. So the opposite of plus 1 would be to subtract 1. And whenever we're dealing with an equation, whatever we do to one side of the equation, we have to do to the other side of the equation to keep the equation balanced. So I'm going to subtract 1 from the other side of the equation. So positive 1 and negative 1 will cancel each other out. And on the left side of the equation, I have a 3x. On the right side, I have 13 minus 1, which is 12. Now, as I said before, when we have a number touching a variable, that represents multiplication. So to undo multiplication, or the inverse operation of multiplication, is division. So we're going to divide by 3. Again, whatever we do to one side of the equation, we have to do to the other side of the equation. 3 divided by 3 is 1. We say that it cancels out. It doesn't actually cancel out or go away. It turns into a 1. So then we have 1x. So we don't need to write the 1 in front of the x. This is telling us we have an x. There's 1x. Equals 12 divided by 3, which is 4. Now, we can always check to make sure that our solution is correct by taking the answer that we get for the variable and plugging it into the equation for the variable. So since we got that x is equal to 4, we can take 4 and plug it into the equation where the x is. So that's what I'm going to do to check my solution. All right, 3 times 4, remember if I have a number and a variable touching, that means multiplication. 3 times 4 is 12 plus 1 equals 13. Well, 12 plus 1 does equal 13. So that tells me that my solution of x equals 4 is correct. Let's try another example. Again, our goal is to isolate the variable, so we're going to start moving things away from the variable, and we start with addition and subtraction. Well, even though I see a minus sign in front of the 5x, that is just the sign of the number. I'm not subtracting 5x from anything. However, I am subtracting 2 from the 5x. So I want to undo that subtraction, undo minus 2, so I'm going to add 2. And again, I'll add it to the other side of the equation. The 2's cancel, and I get negative 5x equals 15. Okay, to get the x by itself, we're going to divide by negative 5. And I get x equals a positive divided by a negative is a negative. 15 divided by 5 is 3. So my solution is negative 3. In this example, we have variables on both sides of the equation and constants on both sides of the equation. Well, we want to get the variables on the same side of the equation and the constants. Now, a constant is a number without a variable. We want to get those on the other side of the equation. It doesn't matter if the x is on the left side or on the right side, as long as it's by itself. So we can, when we have a situation like this where we have variables on both sides and constants on both sides, it doesn't matter which one we move first. So we can choose any one of these four terms to move first. I'm just going to go with this minus 8. So to undo minus 8, I'm going to add 8. And then I need to add 8 to the other side of the equation. So the negative 8 and the positive 8 cancel each other out. I'm going to bring down what's left. I have 16x is equal to 36x. And then 7 plus 8, positive 7 and positive 8 give me a positive 15. Now, I want to make you aware that whenever I moved the 8 to the other side of the equation, there were two terms on the right side of the equation. I did not add the 8 to the 36x. I only added the 8 to the 7 because the 8 and the 7 are like terms. Remember, we can only add or subtract like terms. Because 36x and 8 are not like terms, I did not add 8 to the 36x. Okay, so now we have 16x is equal to 36x plus 15. Remember that I want the x's on the same side of the equation. Now, be careful not to get your equation lopsided. What I mean by that is you shouldn't get all of your terms on one side of the equation. So I do not want to subtract the 16x because that would put nothing on one side of the equation. Instead, to get the x's together, I want to subtract the 36x. That way we keep something on each side of the equal sign. 16x minus 36x gives me a negative 20x equals 15. Now to get the x by itself, this negative 20 and the x are being multiplied, so the opposite of multiplication is division. And I have x is equal to this negative 15 over 20. Anytime we have a fraction, we should reduce our fraction. And the way that we reduce a fraction is we have to figure out what number is the biggest number that will divide evenly into both the numerator and the denominator. Well, the biggest number that will divide into 15 and 20 is 5. So first of all, this was 15 divided by negative 20. This fraction means the same thing as 15 divided by negative 20. So a positive divided by negative is a negative. And then 5 will go into 15 3 times, and it will go into 20 4 times. So my solution is x equals negative 3 over 4, or 3/4. Now in this example, our equation is given to us lopsided. So if you'll notice, there's a 0 on the right side of the equal sign. If it's given to us lopsided, there's nothing we can do about that. My advice is just not to create a lopsided equation. So in this equation, our first step is to combine like terms. So if we look at the equation, our like terms are 5x and negative x, and we have a negative 9 and a positive 5. Now, when we have terms that are already on the same side of the equation, we do not do the opposite operation to combine them. If I want to combine 5x and negative x, that's the same thing as 5x minus x. So 5, let me rewrite that. 5x minus x, and then negative 9 plus 5. So I just rearranged that so you can see the like terms next to each other. Okay, so 5x minus x, or minus an understood 1x, would be 4x. Negative 9 plus 5 would be minus 4, equals 0. So, like I said, if it's already on the same side of the equation, we don't change the signs, we don't do opposite operations, we just combine our like terms. Now to get the x by itself, we have to start moving things away from it. We got to start moving things to the other side of the equation, and that's when we do the opposite operation, only when we're moving a term from one side of the equation to the other side of the equation. So to get the x by itself, the first thing we do is undo addition and subtraction. So I'm going to undo minus 4 by adding 4. And again, do it to the other side of the equation. And that gives us 4x equals 4. And then the last step would be to divide by 4, which gives us x equals 1. Now we're going to solve equations using the distributive property. So as I said in the steps to solving a linear equation, the first step is to combine like terms, and the next step is to isolate the variable. Well, if there are parentheses in our equation, the first step becomes getting rid of the parentheses. Then we combine like terms and isolate the variable. Okay, so to get rid of the parentheses, we use the distributive property. The distributive property tells us that if we have a term that's touching a set of parentheses, we can distribute that term into the parentheses by multiplication, and then that gets rid of the parentheses. So that's what I'm going to do. I'm going to distribute this negative 4 into the parentheses using multiplication. Negative 4 times x is negative 4x. Negative 4 times negative 3, that would be a positive 12. And we only distribute it to the things in the parentheses, so we do not distribute that negative 4 to the negative 2 on the other side of the equation. I just bring down that negative 2. Now this looks like an equation that we have been doing, a regular multi-step linear equation. So now that the parentheses are gone, we want to combine any like terms, which we don't have any like terms that are on the same side of the equation, so we need to start isolating the variable, moving things away from the variable, and we start with addition or subtraction. So we have the plus 12. I'm going to subtract 12. That leaves me with negative 4x equals negative 14. And then I divide by negative 4. And again, this will be a fraction. So a negative divided by negative is positive. So that would be a positive 14 over 4. The biggest number that would divide into 14 and 4 is 2. So 14 divided by 2 is 7. 4 divided by 2 is 2. So x is 7 over 2, or if we wanted to change it to a mixed number, it would be 3.5. In this equation, we have two sets of parentheses, so we need to get rid of both sets of parentheses by distributing whatever is touching the parentheses into the parentheses. So this 3 is going to be distributed to the 4 and the x. The 2 will be distributed to this x and this 8. Again, using multiplication. When I distribute the 3 to the 4, that's 3 times 4, which is 12. Then 3 times x would be 3x. 2 times x is 2x, and 2 times 8 is 16. Now we want to get the x's on the same side of the equation and the constants on the same side of the equation. So just like earlier, if we have a variable on each side of the equation and a constant on each side of the equation, it does not matter which term you move first. I'm going to move the 2x. So this is a positive 2x. So to move that, I'm going to subtract 2x. We try to think about what we have to do to it to make it go away. So 2x minus 2x, that would cancel out. That would be 0. So that would make it go away. So I have to do the same thing to the other side of the equation. Remember, we only do it to the like term when we're adding or subtracting. So I'm going to subtract 2x from the 3x. So that leaves me with 12 plus 3x minus 2x is 1x. And like I said before, if we just have 1, we don't put the number 1 in front of it. We just put that we have an x. This is 1x equals 16. Again, I do not want to get my equation lopsided, so I'm not going to move the 16. I want the x to be by itself. I want to get rid of the 12, so I'm going to subtract 12. And that gives me x equals 4. Okay, this equation only has one set of parentheses. Let's get rid of it by using the distributive property. So this 4x plus 1 is just going to stay 4x plus 1 for right now. And on the right side, I distribute the 3. 3 times 2x is 6x. And 3 times 5 is 15. Once again, we have an x on both sides and a constant on both sides. It doesn't matter what we move first. I'm going to move the 1. That's plus 1, so I'm going to minus 1. And that gives me 4x equals 6x plus 14. Now I need to get the x's together. Which x should I move? not the 4x because that would get me lopsided. I need to move the 6x. So now I have 4x minus 6x. That would give me a negative 2x equals 14. And then once again, we divide. So I'm going to divide by negative 2. And that gives me x equals negative 7. All right, this is the last example. If you'll notice, we have two sets of parentheses, but they're on the same side of the equal sign. Now remember, we only distribute whatever is touching the parentheses or what is in front of the parentheses into the group. So in this group, the 2 is in front of the parentheses, touching the parentheses. So I'm going to distribute the 2 into this set of parentheses. What's touching this set of parentheses, or what's in front of this set of parentheses? It's a negative sign, but that can also be thought of as a negative 1. So that will be distributed into this set of parentheses. All right, so 2 times x is 2x. 2 times negative 5 is negative 10. Negative 1 times 7 is negative, or 7x. Negative 1 times 7x is negative 7x. And negative 1 times positive 1 is minus 1. So now, again, we need to combine like terms. My like terms are 2x and negative 7x, and negative 10 and negative 1. So you can just combine the like terms, or you can rewrite it and put the like terms next to each other. 2x minus 7x, and then we have the minus 10 minus 1 equals 6x. All right, 2x minus 7x would be a negative 5x. Negative 10 and negative 1 is negative 11. Okay, we need the x's together. So which x should we move? Not the one that's by itself, because we don't want to get our equation lopsided. So we're going to move the negative 5x by adding 5x. Okay, so I have negative 11 equals negative 1x, or negative x. And I want my x to be positive, so I'm going to divide by negative 1. And that gives me a positive 11 for my solution. And that's how we solve multi-step linear equations. Thank you for watching.